Okay, question 20. We want to write the logarithmic equation corresponding to the graph shown. And we're going to use f of x, which is equal to the log of base 5 of x, as the parent function. So the first thing we want to do is determine what's happening with the graph. Well, the graph from left to right is a decreasing function. So if it's a decreasing function, then we can start out with this form, f of x, which is equal to negative a, since it's a decreasing function, times the log of base 5 of x plus c plus d. Okay, and then the first thing you want to do is look at the graph and determine where the vertical asymptote is. So you can see how it's leveling off at here. So the vertical asymptote is located at x equals negative 1. So that tells us that c is going to equal 1. So far we have f of x is equal to negative a times the log of base 5 of x plus 1 plus d. Okay, so next we want to find a nice point, okay, that passes through the origin. In this case, it passes through the origin at 0, 0. So we know that f of x is equal to 0 and x is equal to 0, and then we're going to plug it into this form. So f of x is 0. We know that x is 0. And then we still have 0, and then over here we get 0 plus 1. Now, anytime you take a logarithm of 1, regardless of the base, it's always going to equal 0. And 0 times negative a is 0. So now we have d, which is going to equal 0. So now we know that d is 0. So far, in number 4, we have f of x, which is equal to negative a times the natural log of 5 times x plus 1 plus 0. So we don't have to worry about that 0. Now the next thing we want to do is find this value of a. So we're going to pick another point on the graph. So this other point on the graph is positive 4, negative 3. So we know that f of x is going to equal negative 4 and x is going to equal 4. So now we can solve for a by rewriting this function. So f of x is going to equal negative a times the log of base 5 of x plus 1. Plugging in f of x to be negative 3. We're plugging in x to be 4. So we have negative 3 is equal to negative a times the log of base 5 of 5. So if we evaluate the log of base 5 of 5 is right here. So let's rewrite that in terms of an exponential expression. Y is the exponent on base 5 to get 5, and that's 5 to the 1. So basically this log of base 5 of 5 becomes 1, and that's 1 times negative a, which is equal to negative 3, and therefore a is going to equal 3. And now we have our function, f of x, which is equal to negative 3 times the natural log of base 5 of x plus 1.